So you're probably thinking to yourself, oh my gosh, adding real numbers. We've been doing this since 1954. Well, maybe not you guys, but you have? You've aged well. All right. So adding real numbers, we start getting into the whole positives, negatives, that kind of stuff. First vocab word, additive identity. Now, when you think identity, it's what a person is. Your identity is who you are. Well, we have a number in math that we can add to anything and not change its identity. What number could we add to anything and not change it?
0.
0, yeah. So the additive identity is just a fancy word for the number 0. Because any number x plus 0 is going to be that same number x. It doesn't change its identity. Then we've got this other word, fancy word, additive inverse. Inverse is just a really fancy word for opposite. Okay. The additive inverse of a number is just its opposite. The word inverse literally means flip. Why is my example 4 and negative 4? Why are those two numbers inverses of one another? Can?
Because 4 is the opposite of negative 4.
Yeah, 4 is the opposite of negative 4. So, little theoretical question. What's the sum of inverses always going to be? What is the sum of inverses always going to be? Shower?
0.
Why?
Because no matter what you do, you're always subtracting the same numbers you're adding.
Yeah, if you add inverses together, if you add two opposites together, they're going to cancel each other out and always give you 0. Very good. Okay. All right, what do we got next here? Adding two integers using a number line. Now this is a really elementary way of thinking about it, but at least gets us thinking in that addition mode. Use the number line to find the sum, negative 5 plus 7. We'll start at negative 5, so go ahead and make a dot at negative 5. And if we plus 7, which direction do we move?
Right.
Yeah, plus is going to the right. So we'll add 1, 2, 3, 4, 5, 6, 7. So we move 7 units to the right. Come on, pen, keep up. Holy buckets, there we go. Okay, and where do we end at?
2.
2. So negative 5 plus 7 is?
2.
2. That wasn't so bad, huh?
Oh, sure.
That was?
Yeah, I was like, use my brain.
No comment. All right, negative 3 plus negative 4, where do we start? Start at negative 3. But what's the difference here? If I add a negative, which direction do I have to move?
To the left.
Yeah, if we add a negative, we have to move left. 1, 2, 3, 4. So started at negative 3, we moved 4 units to the left, and where do we end at? Negative 7. Negative 3 plus negative 4 is?
Negative 7.
You guys got it. Now, we want to be able to do this without a number line. Okay? We're going to teach you some mental math tricks for how to add and subtract positive, negative numbers. But if you really needed to resort to a number line, I suppose you could always fall back on it. Here's the big idea, rules of addition. If you add two numbers with the same sign, okay, let's say I had 5 plus 3, or let's say I had negative 5 plus negative 3. If I have two numbers with the same sign, so positive, positive, and a negative, negative, what's the sign going to be for the answer? Tipka.
Well, 2 positives are always a positive.
Okay.
2 negatives are always a negative. And then a positive and a negative could be either one.
Oh, yeah. Okay. Depends on which one's bigger, right? So what we have are these rules of addition that kind of can clarify it no matter what. Okay, if we have the same sign, forget about the sign. Forget about the positives and negatives for a second and just add their absolute values. Add the numbers. And the sum, whatever those two numbers give you, is going to have the same sign as what they were. Okay. If you had negative 5 plus negative 7, some people are like, oh, I'm just not good with negatives, Mr. Hilliard. I said, well, forget about the negatives. What's 5 plus 7? 12. And they're both negative, so your answer is going to be negative. Okay. If you owe somebody $5 and then you owe them $7 more, you're going to owe them even more. You're going to owe them $12. But now Tipka, you said sometimes if you add a positive and a negative, it could be either one, right? So here's my rule for adding two numbers with different signs. Okay, I like thinking about it this way. Ready, doll? Yule? Okay. Subtract the smaller absolute value. Okay. Take the bigger number minus the smaller number. Ignore the symbols. Just take the bigger number minus the smaller number. The sum is going to have the same sign as the number with the larger absolute value. Okay, let's put that idea into action here. You've got negative 10 plus 4. Forget about the negative. Which number is bigger?
10.
10. Take the bigger number minus the smaller number.
6.
10 minus 4 is 6. The bigger number wins. The bigger number was negative, so your answer is going to be negative 6. Completely forget about the negatives. Just deal with the numbers that you're comfortable with, and then the bigger symbol wins. All right, let's jump to example 2. It says find the sum. Negative 2.5 plus negative 4.2. Forget about the negatives for a second. What's 2.5 plus 4.2?
6.7.
What is it?
6.7.
Yeah, 2 and the 4. I like to just break it up into wholes and parts. The wholes, 2 and 4 gives you 6. 0.5 and 0.2, 50 cents plus 20 cents is going to give you 70 cents. Okay, I'm not sure why they give us this extra space. But yeah, you're going to get a 6.7. They're both negative, so the answer is going to be negative. Okay. How about part B? 10.5 plus negative 15. Use our rule. What's the rule when they're opposite symbols? Stuart?
Just forget the negative sign and just add them.
Not add them, but
Minus
yeah, forget the negatives. Just take the bigger number, which is
15.
and subtract the smaller number.
10.5.
Okay? 15 minus 10.5. What's that, Ken?
4.5.
That's 4.5. So is my final answer 4.5?
No.
Shower, what is it?
Negative 4.5.
Why?
Because the bigger number was negative.
Bigger number was negative. Bigger number wins. Okay, bigger number wins. It was negative, so my final answer is going to be negative. Now, I didn't follow the blanks exactly how they probably wanted me to, but we get the idea there. Okay, let's have you guys practice a couple. Try checkpoint problems number 1 and 2. When you think you've got them, raise that mono and I'll check them out. Okay, let's take a look. Who's got number 1? Riley.
Negative 10.
Negative 10. Forget the negatives. 7 and 3 gives you 10. They're both negative, so our final answer is negative. Who's got 2? Julia.
7.5.
7.5. If you have opposite signs, take the bigger number minus the smaller number. 9 minus 2 is 7. Bigger number wins. The bigger number was positive, so our final answer is positive. Very good. All right. How about fractions, though? This is where having those rules, the addition rules that we talked about, this is where it can really be a benefit. Okay, you've got negative 7.5 plus 10 3/4. Forget about the negative for a second. How could we use our addition rules to think about this problem? Riley?
You just do negative, or 7. You just write 3 right away.
Okay.
Negative 7 plus negative 10 is 3.
Okay, so what he's saying here is, okay, take your bigger number minus your smaller number, right? Forget about the negative 7.5. Just think of it as 10 3/4 minus 7.5. Take the bigger number minus the smaller number. Now what you said, Riley, is focus on the wholes first, right? What's 10 minus 7?
3.
3. Now deal with your fractional parts. What's 3/4 minus 1/2? What's 75 cents minus 50 cents? Taishana? 25 cents, which as a fraction would be 1/4. Okay. Now we have to look and say, well, is my answer going to be positive or negative? The bigger number was positive, so my answer is going to be positive, 3 1/4. 3 1/4. Okay. And this is another example where your second chapter test, it'll be no calculator. Okay. You might have a question like this. I won't give you like, -7 4/64 plus 7 2/7. Okay, I'm not going to give you something crazy like that, but this we should be able to do. All right. Let's have you guys try this one. Okay, try 8 2/3 plus -9 1/6. Just in the margin there where it says your notes. Let's walk through this one. This one's a little tougher. Just because our brains, it's a little tougher to conceptualize thirds and sixths. But if we follow our addition rules, the addition rules say, hey, if I've got different symbols, if I've got different symbols, take the bigger number minus the smaller number. What's the bigger number up there? 9 1/6. And let's subtract the smaller number. Now, anytime you're dealing with fractions, you need to have a common denominator. So between 1/6 and 2/3, what would my common denominator be, Stuart?
6.
How many sixths is 2/3?
2.
No? I know what you mean. You have to double both of them, right? So how many sixths do you have? 2 times 2, you've got?
4.
4 over 6. Okay, so now I want you to break it down. Take your wholes first. What's 9 minus 8?
1.
What's 1/6 minus 4/6?
Okay, do just 1 for 1.
You do, don't you? But what's 1 minus 4?
-3.
So you've got 1/6 minus 4/6 is -3/6. What's 3/6 the same as? 1/2. So really you've got like 1 minus 1/2, which is a half. So is that my final answer?
Yeah. No. Take a negative.
Remember, the last thing we do in our addition rule is we say, bigger number wins. The bigger number was negative, so our final answer is going to be negative. Okay? Just one way of thinking about it. All right, a couple properties of addition that we need to talk about. These kind of make addition work. Unique properties of addition. The first one's called the commutative property. How many people's parents commute to work?
Isn't that just going to work?
Going to work? They go there, right? They commute to work, they drive there, and then they commute back. Okay? Is the distance they drive from work to home the same as when they drive from work, or when they go from home to work, the same as when they go from work to home? No. Even if there's traffic, the time might be different, but isn't the distance the same?
No. Oh yeah, unless there's any construction on the road.
You guys, all these conditional cases. Mark,
My dad works for a betting company, so he never takes the same route.
you're killing me right now.
My dad stops
Jeez.
at McDonald's every day.
Well, if it's every day, then it's still the same.
My mom got it.
What's 5 plus 3?
Just kidding.
What's 3 plus 5?
8.
So, when you're talking about addition, does order matter?
No.
No, that's what the commutative property of addition says. It says if you take a plus b, that's going to be the same as b plus a. Or a numeric example, -1 plus 3 is the same as 3 plus -1. Now, the reason I'm talking about your parents commuting to work is if I just give these to you, you're not going to have any way of remembering them. You have to have a trick of transferring things from short-term to long-term memory. So I'm trying to give you a trick here. If you look at the word commute, okay? You think of your parents commuting back and forth. Home to work is the same distance as work to home. They travel to work, they travel to home. The distance is the same, either way they go, back and forth. I'm just trying to give you little tricks to remember what the commutative property is. The next one is the associative property. Okay? Root word of associative is associate. Your parents, hopefully your parents never said this to you, but maybe they have. I don't like who you're associating with. Your parents ever say that to you? What are they saying when they say, I don't like who you are associating with? Taishana? Don't like who you're talking with. I don't like who you're hanging out with. Right? And when you're hanging out with somebody, that's kind of your group. Well, that's what associative property is all about. It's talking about a group of stuff. See, A and B are at the party already, because we had to do grouping symbols first. A and B are at the party, C shows up. Well, the bottom line is A, B, and C are all at the party. That's no different than if B and C are at the party, first, and then person A shows up. Either way, person A, B, and C are all at the party. All the associative property does is it shifts the grouping symbol. It shifts who you hang out with. Okay, A and B are hanging out first. Here, B and C are hanging out first. It doesn't make a difference. 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, right? Doesn't matter how you look at it. Either way, you've got 6. Identity property, we already touched on that one a little bit, but any number plus 0 is going to be? Any number A plus its 0 is going to be 0 plus the number, it's going to be that number. 4 plus 0 is going to be 4. The inverse property, we kind of talked about inverses as well. Inverses are like opposites. When you add a number at its opposite, you're always going to get? 0. Very good. Okay, -9 plus its opposite is going to be 0. Okay, so what I want you guys to do is you've got that list of properties. I want you to tell me which property is illustrated right here in example 3a. X plus 5 equals 5 plus x. Which one is that page?
The commutative property.
Good. The commutative property. Okay? This would be our commutative property of addition. Why? Because they commute to work, they commute back, the distance is the same, the order isn't important. How about y plus 0 equals y? Which property is that?
The identity.
Yep, that's our identity property. Any number plus 0 is itself. Okay, jump to checkpoint problem number 3. -5 plus 5 equals 0. Which property is that? Gain.
Inverse.
This will be our inverse property. I'll abbreviate inverse property of addition. And then last one, -5 plus 2 plus 3 is the same as -5 plus the quantity 2 plus 3.
Social.
Come on. You guys, jeez. Yes, ma'am.
Okay, so on the homework, if we have to do homework today, right?
We do, yep.
Okay. We have to write down like a whole, like,